Today's presenter is Grant Ingersoll. Grant is the CTO and co-founder of Lucidworks and is also a Lucene Solr committer. Thanks for joining us today, Grant.
Thanks, Aaliyah. Glad to be here, and thank you to everybody who's joining us. Today I'm happy to be giving a webinar on the introduction to Lucidworks Fusion. With that, I'd like to kind of start off by setting a little bit of the stage and felt the need to build this product and how we think that will help our customers and help people interested in building next generation search applications. So one of the things that I think is really core to where search is at these days is that search has become so much more than just that little box in the upper right-hand corner of a website or of an application that helps you find the little things in that application. It really has become intrinsic to everything we do in life, whether that's finding directions to our favorite restaurant, looking up and doing research on the web, or connecting with our friends in our social networks. It really has evolved over time to become much more of an experience. And so when we think about search here at Lucidworks, we think about how can we deliver products built on the greatness of Apache Solr that help you personalize your experience for your users, for your customers, et cetera. How can you bring more context to those applications, to your data, et cetera? But ultimately, how can you make that data actionable? And so we really want to package together a product that helps deliver on that experience. And it really builds on top of what we've seen in the search market and how that search market has evolved. When you take something like Apache Solr, for instance, it's all about search at scale, and that really is kind of the left-hand commodity level capabilities of search these days. I want easy out-of-the-box search capabilities that I can scale to handle billions and billions of documents. When you go into the enterprise, of course, you want to bring in things like security, data workflows, data connectors, et cetera, et cetera. Enterprise search has also been evolving to not only capture kind of the old go crawl all of our corporate intranet, but deployed in search within a cluster within the enterprise, search within lots of different applications, et cetera, et cetera. But ultimately, where I think more and more of this market is going and what we've been targeting from a Lucidworks Fusion standpoint are these right two most items, the advanced search and the big data search. How can we leverage all of the greatness and cool things that search and Lucene and Solr bring to the table in terms of their discovery and text analytics and dealing with numbers, et cetera? How can we bring those things to the table such that you're able to power things like recommendations, personalization, analytics, and how can you then couple that with ecosystem tools like Hadoop and Zookeeper and Hive and Pig and Spark and and really build out next generation applications that just aren't just about search, but are really about how do you help create a virtuous cycle between your users and their data. And that ultimately is what we are after. So in terms of the rest of this webinar, I'm going to just give a quick introduction to Lucidworks for those who aren't familiar with the company. And then we're going to dive into the key concepts and features and functionality around Fusion. We'll look at the architecture. We'll talk a little bit about how all of this stuff scales. Then we'll finish up with a quick demo, and I'll be available for answering your questions. Just as a reminder, if you do have questions, pop them into the Q&A box on the webinar. With that, I'd like to just do a quick introduction to Lucidworks Search. We are, at the end of the day, a search company. You can see from the logos, we span lots of different industries. We ultimately help people solve data access problems. And the way we do that is starting on the foundation of Apache, Lucene, and Solr. We employ a large number of the committers that contribute to those projects. We contribute large volumes of code back to that project and those projects. And then we extend those capabilities through products and services that enhance those capabilities. With that, then, the announcement today is all about our next generation product, that is that extension of Solr. And so with that, I'd like to get into introducing Lucidworks Fusion. When we sat down at the whiteboard to figure out what we wanted to do for our next generation product, two things kept coming to mind in terms of where we were at. And then out of that spawned a number of features and functionality, et cetera, that we wanted to incorporate into the product. And one of the first things that came to mind in designing the product is that when you look at data access, when you look at search, when you look at what's happening with tools like Google Now and Siri and Facebook, et cetera, Amazon, it really, you come to this conclusion that the signals that all of us as people interacting with those systems are what power modern relevance and power modern insights into the data. And so we wanted to bring those capabilities into Solr. We wanted to make those easier for our customers to leverage. And we wanted to ultimately make it so that you could capture all of this great feedback information that you have about your data, such that you could then improve access, you could improve insight, you could find the gaps in your data, you could find the gaps in your users, and bring all of that together such that you have a much richer and more powerful experience for your customers. We do this at index time, we do this at query time, and we can do this when displaying the results. Signals in this case can range from things as in e-commerce like clicks and ratings, or in knowledge management, they could be things like the fact that 2 people within a company emailed on a topic. We could incorporate things like social media around tweets and status updates. And they also could, in fact, factor in the mobile space and where people are located, what they are doing at any given point in time. All of those little bits add up to lots and lots of power in terms of harnessing what people are doing and what they're interested in, such that we can provide better and deeper access to data in more relevant ways. So that was the first key concept. The other thing that we kept coming back to is we know there's lots and lots of Solr out there, and we know there's lots of interest in scaling Solr, and that we know that we can do lots of interesting things within Solr. So we really wanted to simplify the operational aspects of deploying and accessing data at scale. And so we just kept saying to ourselves, hey, why don't we just go deploy more Solr? We need to index all of our logs, or we want to do analytics on our logs, or we want to store signals, or we want to store user information. We want to store our natural language processing models. We just kept coming back to that we can do these things in Solr, because at the end of the day, Solr is a first-rate NoSQL store. And then we've added a number of capabilities on top of that, such that we're really looking at how can Fusion overlay on top of Solr. So we can use Fusion, for instance, to store blobs in there. We can store all kinds of different data. The other beautiful thing that's going on here is that if you have Solr already, you can simply point Fusion at Solr, and now you have first-class administration capabilities. You get all the signal processing I talked about, the recommendations, the analytics, the built-in functionality that comes with Solr. If you don't have Solr, we ship with Solr, and so you don't even have to worry about setting that up. It's all taken care of when you download the product. Digging down a little bit from those concepts, we really started to look at what are some of the things that we can do to make it easier for people to build search-based applications that really capture a number of these things. And one of those that we very quickly concluded we needed was the ability to dynamically change index and query time behavior in front of Solr, such that an application can talk to our pipelines. We can drag and drop and design these pipelines, deploy them as we see fit after testing, and really allow application designers, business analysts, people, et cetera, figure out what they want, try it out, and deploy it without having to go do a full code release, going to have to go do deploy Solr, restart Solr, et cetera. So some examples of pipelines that we have on both the index time and query time are things like the ability to simply turn on a pipeline that says, take advantage of those signals and give me recommendations back when a user does a query. We can also, for instance, set Solr parameters like facets, et cetera, very simply and easily from the pipelines. I'll show you some of that during the demo. We also made it really easy for you to plug in your own capabilities through JavaScript and other scripting languages. Finally, we've also integrated a number of individual modules that we previously had shipped, like our named entity extraction capability, as well as a number of others. So pipelines really are one of the cornerstone things that we provide out of the box in Lucidworks Fusion. Another one that we really took to heart is that customers want it. They want the ability to get data into the system faster and more quickly, as well as at greater and greater scales. And so we took our connectors from Lucidworks Search 2X, our previous version of our product. We've enhanced them in a number of different ways. We've made them easier and more scalable than ever. We've also made them easier than ever to plug in your own. We now ship with 25 plus out-of-the-box connectors, including several new ones designed for the cloud environment we live in, things like Dropbox and Box.com, etc. We've also made connecting with the Hadoop ecosystem much simpler and easier. The ability to connect, for instance, with Hive, you can treat Solr as a Hive table if you want, and then you can also extract data from Hive and index it into Solr. The last big one that we're really excited about in terms of connectors is that we've overhauled our web and file system crawler to be much more scalable, much more reliable, and have a number of new capabilities. This really was designed from the ground up to address some of our customers' most complex crawling needs. And I think we've really done a great job of addressing that in terms of its ability to ingest content at scale and process that in new ways that are much more flexible than our previous crawler. Last but not least, this is an area that we continue to invest in. You will see in our next, our coming releases, support for repositories like Google Drive, Jive, Confluence, Jira, and a lot more. Going off of connectors, one of the other things that we continuously heard from our customers is they want the full round-trip view of that data. And so we baked right in pretty extensive log analytics capabilities such that with a click of a button, you can turn on and start indexing all of the logs that are happening in the system. And we just simply send these to a new collection in Solr, and then you can search them just like you search your regular product catalog. We've also baked in our Banana or Silk products such that you have first-class visualization of those systems or of those logs right out of the box. We also can use those visualization dashboards for looking at things like our signals index and our metrics index and a lot of other reports in the system. The other big thing that we've done with logs is we've actually taken the Logstash piece that's part of Silk and we've made it work as a first-class citizen within the Hadoop environment, such that if you are like most people and store your archival log information in Hadoop, and then you use Logstash for your real-time indexing of logs, you can simply share that same configuration between both of those systems and index all of the content, all of the log content that you have in HDFS, as well as all of the real-time log data flowing in without having to go and try to figure out how to do that in Pig or MapReduce, etc. You can just simply use that with our Hadoop connector. Naturally, one of the key things that we're trying to address with our products are security. We've put a lot of energy and effort into making sure that we address the three most common issues with security: authentication, authorization, and encryption. We've added all of these capabilities into the system such that you can take and interact natively with your LDAP, with Kerberos. We've also added things like fine-grained authorization for both the UI and the APIs in the system such that you can have secure access all the way down to the verb level of the API. And last but not least, we wanted to make sure we provided encrypted communication, so we have first-class SSL support in the system as well. One of the other big features and factors that we were really interested in addressing is the getting started aspect of building a search application. We know a lot of users out there maybe are new to search. They've worked with databases. They're familiar with those things. They've tried Mongo, for instance, or some of these other NoSQL stores. We wanted to make it super easy for people to get in new data, search against it, visualize it, and be up and running very, very quickly. So we've gone and made JSON a first-class citizen in this system so that you can just start indexing JSON like you would with some of the other NoSQL stores. But we've gone beyond that and also have first-class support for a number of other data formats such that we don't want to have to require you to migrate all of your data to JSON if you don't want to. So you can take all of that data, hit it against our APIs, and then be off and running in terms of searching and indexing. Last but not least, we wanted to address both developers and non-developers alike. So the developers, of course, will love the RESTful APIs that we have in the system, and the business analysts and non-developers will love the user interface that we have in terms of being able to very quickly build and crawl and acquire content and build simple web applications right out of the box. So getting started is all well and good, but one of the things that we really focus on here at Lucidworks is how do we help people get finished. It's one thing to get started, but if it then takes you significantly longer to get finished, then that's going to be a problem. And so we focus quite a bit of our time and energy on providing comprehensive management operation tools. We want to give you things like pipelines, et cetera, such that it just simplifies the work that you have to do to be successful in building a search-based application. And of course, because we're building on top of Lucene and Solr here, which are tried and true production search capabilities, we think we can help shorten your time during places like QA, load testing, staging, and then ultimately production with reduction in things like data loss and split brain issues and stuff like that. So what does all of this look like in terms of capabilities? This is a architecture, if you will, of Lucidworks Fusion. You can see at the core here is Apache Solr. We start with that and build on top of it, such that things like all of these things around it, like the analytics store, the enrichment services, discovery engines, those all work and extend as Solr capabilities, such that we can then provide enhanced processing on top of this platform and drive things like recommendations, drive things like signal processing, drive things like analytics. We then take and put all of that behind a cohesive set of secure APIs from which we can then go up to the top layer here and build out applications, user interfaces, etc. Last but not least, you can see also here on the left-hand side that we make our connector framework available inside of this system as well, such that it's very easy to get content in. And so, for instance, when you look at something like the recommendation module, and I'll show this during the demo, we take raw signals, we take all of that content that's flowing in about how users are interacting with the system, and we flow that right back into Solr such that we can then take and do interesting analytics and aggregations on top of that data and then feed it back out as something like a recommendation. So that's the Lucidworks Fusion architecture. I'm happy to answer questions afterwards on that. Last but not least, I said I would talk a little bit about scale before the demo. I think one of the interesting things that we've been doing as a company is really focusing on making sure that Solr and Solr Cloud, the distributed aspects of Solr, are really ready for prime time. We've spent a lot of time and energy amongst our committers really baking this out. We've seen repeatedly from customers doing bake-off that we scale better and faster than other engines on the market. We've taken an interesting approach in terms of how we help people deal with cluster resizing issues in terms of shard splitting, such that we think we have a very flexible solution that allows you to add or take away capacity without having to re-index your whole entire set of content. Last but not least, we chose as a community Apache Zookeeper, the tried and true approach to distributed leader election and things like that, distributed file systems, as the basis for how we coordinate our distributed activities. And I think one of the key things this brings us is the ability to really focus on minimizing data loss and avoiding things like network partitions, etc. One of the things we are in the middle of doing right now and will be publicizing here very soon is the use of Jepsen for testing network partitions, and the results are looking very promising there in terms of our Solr's ability to deal with network partitions and other problems that often cause data loss in distributed systems. So what does all of that look like? Here's just a brief architecture diagram around how we scale Fusion. One of the key things I want to point out here on the right-hand side of the screen is Solr Cloud. In the lower middle is Zookeeper. If you're familiar with Solr, you know that Solr leverages Apache Zookeeper for doing distributed coordination. In terms of Fusion, we rely on those exact same capabilities. So all of our services up here in the upper middle, the Fusion services area, those are all built to be stateless and work with Zookeeper seamlessly as well to do things like load balancing, leader election, and so on, such that just like we said at the beginning of the feature set here, you can simply go deploy more Solr, and then with Fusion, you're deploying the similar technology in similar ways, hooking it up to Zookeeper and putting it into a web container. Last but not least, we then have a proxy layer that provides our security and other capabilities, and all of that then allows us to go out and serve millions of queries to millions of users and deal with indexing content at very, very large scales. With that, I'm now going to shift gears. Bear with me as I switch my screen here to giving a quick demo on Lucidworks Fusion. So what you see here is our web application, our front-end admin to Lucidworks Fusion. I'm going to log in here, and hopefully I can type correctly, and I cannot. So you can see we actually have security on in the system. One of the things that we do in our application is build on the theme that so many of us are used to with our phones and other applications, and have this idea of a launch pad such that we and our partners will be able to extend the capabilities of Fusion by simply adding in their own applications into this environment. I will give you a little bit of a tour of the admin and the banana dashboards in a minute, but for now, I'm actually going to walk you through the tutorial, which I think highlights some of the key concepts that I've talked about so far. So the first thing we do is we want to get some data into the system. In this case, I want to logically organize that data. So the first thing I'm going to do is create a collection. You can see on the right-hand side here some of the calls that are being invoked on the back end by this system. You can see in the upper right, we provide notifications for you around what's happening in the system, and so on and so forth. The next thing I want to do is get some data into the system. So what I'm going to do is actually create two different data sources. One is a live stream of the Twitter garden hose, which is built right into the product. The other is an example of doing a web crawl. And so what I'm going to do is authorize my Twitter account here. I'm going to hit the login to Twitter button. It's going to pop up and ask me to authorize with Twitter. I've now got permission to index from Twitter, and then I've got another data source set up here that is going to crawl lucidworks.com. And you can see some examples of the relevant API calls that are happening on the right-hand side. I'm going to hit submit. Off it's going to go and create the necessary capabilities on the back end, and that's going to take a little bit of time to start indexing. Twitter's going to start bringing in its tweets, etc. I'm always amazed at how fast data flows through Twitter. But from there, I can start by doing a simple search. I hit the button here. You can see just in that short bit of time, I've got 28 documents in, not a whole lot. But if I go and do some searches from here, this is all live, so you'll have to bear with me. Some of this is Twitter content, and obviously I do not have control over that. But I can do things like search for Lucidworks. I'm going to take a chance here and bet that in that time period that we were talking about, somebody has tweeted something about Apple. You can see here that that's the case, and so on and so forth. So I'm getting both tweets and web crawl documents into the system all at once. So that's all well and good. That's pretty standard content acquisition and search capabilities, all baked into a fairly simple user interface that's designed to give feedback to users in the tutorial right off the bat. What we can then do, though, is start to look at what happens when we do some signal capture. And the way I've modeled that in the tutorial is through these little boxes down here that simulate clicks. And so one of the things that we can do, for instance, is scroll down here a little bit, and let's just pick randomly here this title, Lucidworks brings the power of enterprise search to MongoDB. That's talking about one of the data sources we have out of the box in our system. And let's say that while I'm giving this demo, 100 people came in and actually clicked on that document. And of course, in reality, what would happen is those clicks would be distributed across a large set of the content, or at least, probably the top 10 or top 20. You notice if your eye was quick there, you may have noticed that in the notifications here, what I just did was go and send 100 raw signals to the demo signals index. And so now I've got the raw materials for building out a recommendation or a popularity-based search engine. Now all I have to do is just go do a little work to work that data back into the system. So I'm going to step through to the next stage of the tutorial, and I'm going to kick off an aggregations job. An aggregations job, what this does is take all of that raw signal data and roll it up into aggregates that essentially summarize that signal data. And it's those summaries that we can then use in our searches. And I'm just going to hit refresh here. And you can see that this aggregation job that I kicked off and was running in the background finished rather quickly, and it actually indexed and rolled up those 100 signals into some aggregates. So all of that's well and good. What can we do with that? Well, we can come back in here to search on the next page, and we can you can see here that I'm submitting that same Lucidworks search, and then you can see out of the box using the stages and the capabilities that are built into the pipeline that I'm leveraging in this demo. You can see that now that Lucidworks Mongo item that we had that was down around position 8 is now at the top. And in fact, you can see the score here is significantly larger than the other scores. And that's really accounting for the fact that in this very simple example, the weights are significantly leveraged by the fact that I'm indexing all of those signals. Okay, so with that, you can see how over time and as users interact with this data, the system is essentially learning and improving based on how people are interacting with that. And this signal capture framework is actually quite flexible. We provide a number of capabilities out of the box around signal capture, but in fact, you can also plug in your own as well. So if you have your own formula for signals, or if you want to bring together 20, 30, 40, 50 different kinds of signals into one metric that you can then use to boost your content, you can certainly do that, and it's very straightforward to do. With that, then, the tutorial finishes off with a quick tour of where can you go next from here. I'll show you the admin here in a minute. One of the other things that we have baked in is, if you're familiar with our open source project, we call it Banana. It's a port of the Kibana project to Solr. That is now a first-class citizen in our system, integrated in with the security system such that you can control who has access to what dashboards and when. And as an example, you can just see I've got all of our log data flowing into the system here, and so we could very quickly build out a log-based monitoring system if we wanted to. We also can tie this into the Fusion signals, and then we can also look at all of the low-level system metrics that are happening as well. The other part of the demo here, if you remember, is the admin piece. I will just finish up by giving a quick tour of that. It really starts off by giving you an overview of what's happening with the collections. Obviously, I've got some very simple data sets going on in here, But what we try to do is give you, in a nutshell, a snapshot of the collections, is what's happening within them. Within any given collection, you can see this particular collection is the one I created for the demo. It's got 2 data sources, and it's already got a large number of documents in it in that time period. And from there, of course, you can go and do things like edit data sources, create new data sources. You can manage things like stop words and synonyms, as well as look at things like what is happening specifically in this collection. So those are all baked in out of the box. Some other highlights, we have a very simple search interface built in for people who want to explore what's in the content without having to go build some big application to figure out how to do search. The third item here is really getting at one of those key things that I said was part of Fusion, which is dealing with pipelines. You can see here we've got a number of indexing time pipelines set up, ranging from those that extract content using Apache Tika all the way through to indexing to Solr. And this particular one for the demo I've set up, I can extract content from Tika. I can normalize the data fields on those. And in fact, I can actually extract hashtags out of Twitter fields and then ultimately Solr. If I drill in on this particular one, you can see I can do things like drag and drop the order of how these things happen. I can expand and change them. I can add new features, add new functionality. In fact, you saw all of that was being updated. I can then publish those to real time. Last but not least, as part of the pipeline here is you can actually preview some of these things by putting in your own documents and exploring the results. Similar to index pipelines, we have query time pipelines, and those act in much the same way as the index time pipelines. Finally, the other few things in here, the scheduler really allows us to schedule anything that you want in the system. For instance, we use it to schedule our counters and so on and so forth, or our metrics around what's happening in the system. But you really can, if you want, you can add a schedule, you can have it call back to HTTP, you can have it invoke Solr, and so much more. Last but not least, access within the system is really all available here. You can control users, you can control their roles, and you can control what they're able to see. Finally, the system level insight just gives you a lot more operational view of what's going on, as well as insight into APIs, metrics, what's happening in Solr, what your history of the system is, and so on. With that, I'm going to switch back to the slides and finish up with what's next. Basically, I think we're if you're interested in downloading, you certainly can follow the link here on the screen. If you're interested in exploring the documentation, that's all available at docs.lucidworks.com. And if you wish to reach out to either me or anybody else within the organization, there's some emails and Twitter handles that you can use to interact with us. With that, I will pause and happy to take some questions.
Okay, so we'll now enter the Q&A portion of the presentation. We have some questions that have been asked throughout the session. If we are unable to get to your question, we apologize, and a member of the Lucidworks team will be in touch. So the first question we have, how can we build our own connectors that allow for custom pre-processing? Where can all of the supported data types be found?
Yeah, that's a great question. So in terms of data types, I'll answer that one first. What we do with data types is we rely on Apache Tika for the automatic identification of MIME types. Apache Tika is an open source project. It supports, I don't know, 30 or 40 different data types out of the box. You certainly can plug in your own there as well, but it covers things like Office documents, PDF, images, so on and so forth. We also provide REST endpoints such that if you can convert your data to JSON or CSV and other types of files, you can just start indexing with that content out of the box. As far as writing your own connectors, we do have an SDK available. That's something you should definitely contact us about. We haven't published it officially yet, but we do work with partners and other interested parties to write their own connectors. Typically speaking, it'll depend on the kind of content you're trying to acquire, but, it can range from being as simple as a day or two to get data in up through, longer depending on your security model and those kinds of things.
Okay, the next question is, when is the Windows version going to be available?
It's a great question. We know there's a lot of Windows users out there. We will be making Windows available in our very next release, 1.1, which should be shipping in the November timeframe.
Okay. How easy is it to crawl SQL systems? What resources are available for users on this system?
Actually, that's a great question. I can actually even show that in the system. If we go to the demo page and the data sources here, we can click Add Data Source, and you can see underneath there we have a couple of different databases. If I select the JDBC one, what you then have to provide essentially is your credentials to that database, and then away you can go in terms of indexing and crawling that data. For this particular connector underneath the hood, we're using the data import handler available from Solr, and so the capabilities available in this are pretty much the same, or not just pretty much, they are the same as what's available in Solr in terms of database connectivity.
Is geospatial search supported within Fusion? What tools do you have to visualize this?
So in answering the second part of the question, the tools available to visualize it, Banana has actually a number of different map capabilities baked into it, such that you can do world maps, US maps, etc. In terms of the first question, I guess, obviously since the visualization supports mapping this out, the system itself does as well. And here we rely on Solr's capabilities. If you're not familiar with how Solr does this, it builds out on top of the Java topological suite. We've integrated that into the application such that you can do quite complex geospatial search capabilities right out of the box, whether that's point-based search, i.e. finding all of the content, find me all of the restaurants within 5 miles of my current location, or more complex things like find me overlapping polygons, find me documents along routes, et cetera, et cetera. So there's quite a bit of capabilities in terms of geospatial. I would encourage you to look at what Solr has to offer, and we are, of course, able to answer any questions there as well.
Great. How do we manage business rules and logic for how users interact?
It's a great question. Often one of the things that people want to be able to do is separate their business logic from their core set of code such that it's easier for non-developers to define how search results are displayed, how they're chosen, all of those kinds of things. And so this is really fundamental to our query pipeline approach. Here again, giving a little bit of a demo, you can see, for instance, things like in the demo defaults, I can simply select what facets I want to display here, ranging from field faceting to range facets, et cetera, et cetera. I can also do things like, say, for instance, boost and block documents. I can apply JavaScript to a particular stage such that I have access to the query, to the content, the responses, all of that flowing as it flows through the system such that I can apply my business rules without having to go and modify the core application. And of course, one of the nice things about these pipelines is you can actually set up multiples of these such that you can test which one is more effective for your users without having to redeploy your code or extend your code. And of course, we are pretty actively adding new stages here beyond the ones that we have out of the box. But I think for most people, the ones we commonly see around business rules are boosting and blocking, landing pages, this ability to say, given a query, just take me straight to some URL, and then things like facets and Solr query parameters, and so on.
How do we only crawl new material and not recrawl all of the content each time?
That's another great question. So many of our crawlers have built into them a crawl database that keeps track of what that crawler has seen. Some, of course, some repositories don't support such a notion, but for instance, when you're crawling the web, we keep track of what URLs we've seen. We can do things like deduplication and other things like that, such that we don't want to have to use resources when we don't need to. We can keep track of the URLs and not recrawl them unless they're new.
What are the pipelines built on, JBoss or Drools?
So the pipelines underneath, there's just pretty simple technology that we have built in-house, and then we also have the ability to work with Apache Camel. So if you have Camel pipelines already set up, in fact, you can come in here and exit out and invoke the Camel pipelines from the system. But no, we're not using Drools, and we're not using JBoss.
How does security work within the Fusion system? Is field level security supported? What is added by Fusion to Solr in this regard?
So we do not currently have a field level security. You can secure down to the document level. That's just yet another stage. So in fact, if I wanted to add security trimming based off the user's credentials, I would come in and add the security trimming stage. And what that will do is, as the query is flowing through the system, you pass in the user's who the user is, and then the security trimming stage will interact with the connectors and with the native security of that system to figure out what particular documents are available for that user to see. So that handles kind of document level security within the system. As far as securing the rest of the system, as I mentioned earlier, we provide authentication, authorization, and encryption such that you can make sure that only people are seeing the right data at the right time, and only the right people have access to the right things at the time. And that's all controlled here through the access panel within the system. You can see I can set up my roles, I can set up my users, and I can drill in on what permissions those people have. So for instance, in this case, the admin role has all permissions, whereas the collection admin only has access to certain collections. And you can take and pick and choose your own security permissions here. It's quite extensive when you add your own role or add your own user.
What tools exist for standing up a search front end for end users?
So in terms of front end, in our experience with most of our customers, they're integrating search into their own application. So our primary focus to date on search tools has been to give search out of the box in the system here that's really geared towards people who don't want to spend time building out a complex search. They just want to be able to go in and search the data. So for instance, here we've got a very simple search display. You can, of course, go and build out quite complex dashboards using the banana functionality built in. So you can see I've got search boxes here. I've got all kinds of different displays, all the way down to showing individual results of documents if you want. And so out of the box, there's quite a bit of, hey, get up and get going on a search UI, and then over time, we expect most people will be interacting with the APIs to integrate it into their application.
How many data sources can be crawled at once?
That's a great question. One of the things that we did in comparing Fusion to our previous product, 2.x, a Lucidworks search that had a single process for doing data acquisition. We've taken and built our Fusion connectors on the same technology that we use to build our Fusion services. So if we think about this diagram right here in terms of, excuse me, let me just, so you can see my pointer here. In terms of deploying more Fusion services, connectors are just yet another Fusion service. So you can deploy multiple instances of the connectors, and then they will take care of load balancing, leader election, and all of this kind of distributed things. And so you can actually build out a whole content acquisition farm if you would like. Some of these connectors we will be making fully distributed in terms of their coordination, but right now most of them you can just say, I want this job to run over here and I want that job to run over there, and so you can build out quite extensive content acquisition farm, like I said.
Can jobs be scheduled based on completion of other jobs or just chronologically?
So right now, that is a great question. Right now, we support just chronologically. That is definitely a feature that we have on our roadmap in terms of building cascading type effects. One of the things that you can do in the scheduler as a workaround in the meantime, though, is have it call back to a specific part of your service such that it could then cause that cascading to happen. We were also looking at, extending, for instance, the pipeline capabilities of bringing in to the schedule the ability to script certain actions at certain times and things like that. But we, of course, want to make sure that's done in a secure way and a reliable way.
How can we integrate third-party authentication or authorization systems?
So the way we designed our authentication and authorization systems is to be pretty flexible. We support a couple of different approaches out of the box. We definitely have in mind the ability to integrate with other security systems. As of right now, that's something you would have to engage with us on, but we do have on our roadmap in the fairly short term to add the ability for you to plug in your own authentication and authorization capabilities.
How do you size Solr instances?
How do we size Solr instances in terms of, I'm assuming they're talking about how do we scale those, how many documents and how many queries can a particular Solr node handle? Obviously, it depends on your hardware and your content, but roughly speaking, we've seen customers put on a single instance of, say, like a 16 gigabyte RAM box, modern, CPU processors. Usually they can fit somewhere between 50 and 200 million documents per instance of Solr. And then if they have bigger boxes with more memory, they'll run multiple instances on each of those nodes and then go from there. Obviously, it will depend on some things like what kind of faceting and sorting and other attributes of the system, but we've seen, in my personal experience, I've seen systems that that maybe handle a couple million if they're really large documents or really process-intensive tasks, all the way up to I've seen logging applications where we fit 800, 900 million documents into a single instance, and even beyond that.
This is somewhat of a follow-up question to the last question. What is the minimum number of machines, virtual or physical, required to get this product up and running?
So in terms of the download experience and out-of-the-box experience, this should all run on your machine with, assuming a reasonably sized developer machine. In terms of the actual sizing, I think the minimum we recommend is 5, and then 5 nodes in terms of if you want failover, fault tolerance, all of that kind of stuff. Going beyond that, if you want, a highly robust system with failover, fault tolerance, scaling for both documents and queries, you're often talking, somewhere between 5 and 10 nodes, if not more. range. That's something, though, like when you engage with us or talk to our sales engineers or our solution engineers, they're happy to work through with you what your specific requirements are and come up with a recommendation. For the most part, it follows the guidelines that we put out for Solr.
How do we upgrade Solr versions within Fusion?
So for Solr, we simply just interact and point at Solr. So you're free to do to Solr what you need to do in terms of the best practices and recommendations around upgrades. When you have a support subscription with us, we are certainly happy to help with those kinds of things. But for the most part, we just trust that Solr is there. And in fact, when you set up your system, you can tell us where your Solr instances are. You can actually manage multiple Solr instances all from the same UI. So in fact, you could keep both systems running and point the Fusion application at both systems and then do the switch over when you see fit via the pipelines.
I need to work with some Chinese content. Would I need to use an add-on such as Basis's Rosette, or does Fusion have all of the bells and whistles?
So for other language content, so Solr out of the box has support for something like, 30 or 40 different languages. Obviously, your mileage may vary on the individual language, but for the most part, we provide tokenizers, stemmers, and other language capabilities for those systems, or for those languages, excuse me. As for Basis, you're certainly happy to evaluate them. They're a partner of ours. They have some very good technology in terms of dealing with languages. That stuff all can plug in and work with our system as well. I always encourage people to try the out-of-the-box capabilities provided by Solr, and if it meets your needs, then you're good to go. And if you have more demanding needs or it doesn't meet your needs, then we're happy as a company to give referrals to companies that we know help solve those kinds of problems.
What type of named entities can you extract?
That's a great question. I can actually show some of this here in the demo. In the pipeline stages, so we have multiple approaches to named entities. We have both machine learning-based model approaches as well as rule-based approaches. So for instance, one of the machine learning-based ones that we can leverage is OpenNLP, which is another Apache open source project that provides common named entity extraction capabilities like people, places, monetary units, et cetera, et cetera. We can then also, you can plug in things like regular expressions and gazetteers if you wish to provide your own capabilities there. Last but not least, you of course can plug in your own JavaScript or custom stages. So for instance here, this hashtags stage is simply a regular expression stage, and I could use that, for instance, to look for certain patterns in the data if I wanted. We are also looking at and evaluating other natural language processing tools and how they fit in. Last but not least on this, and I guess it talks about the extensibility of the system. You can actually write and publish into here your own Java-based stages that you, of course, can call out to systems that you may want to use.
How does your platform perform on virtual infrastructure? Does the disk need to be physical?
So, as with anything, as soon as you put it in a virtual environment, there is, of course, some penalty there in terms of performance. So, you need to, of course, size appropriately in terms of disk and memory. From the studies I've seen around Solr on virtual versus physical, it really obviously depends on the capabilities of underlying hardware, but there is some small penalty there. But for the most part, we don't really, that's up to you as somebody provisioning the system to determine. So we run most of our tests in virtual environments and are more than happy with the results that we get from that. So again, your mileage may vary depending on what your particular system is.
So it looks like we're coming up on time here. That was our last question. Grant, was there anything else you wanted to add?
No, I think this is all great questions, and I'm happy able to show people Fusion up close and personal. I would encourage everybody here to go and try the download links, which I have displayed on the screen now. Free to try out, and if you have any questions, we're more than happy to help you answer them on a more personal basis.
Certainly. Thank you, Grant. And thanks everyone for joining us for today's session. Again, we will be sending a link to the webinar recording to all registered attendees within the next few days. It will also be available at lucidworks.com. For more information on our products, you can visit lucidworks.com and follow us on Twitter @LucidWorks. Thanks again for joining everybody, and have a great day.